So, for lesson 8, what we have to do is basically a combination of a few things. We're going to be, well, I'll just paste the I can statement and make this a little bit easier to explain. So, I can find the equation of a line parallel to a given line that passes through a given point. So, basically, what that is saying is if I have some line right here, and I also have some point, okay? What we're trying to do is, if I know the equation of this line and I know the coordinate of this point, then I can find a line that goes through this point that is parallel. And that's the basics of it. Because true, we should hopefully we remember, if I scroll up a bit in my notes here, we went over parallel lines in lesson 6, and then it's about the slopes being the same. They have to have the same slope and they're parallel. Yeah, which is, well and good. But just because we know that two lines are parallel doesn't mean we know that it passes through this line. So we have to be a little bit more specific this time. Now, this may seem like a lot, but to be honest, it's actually, as long as you're okay with what we've done so far in this unit, it won't be too bad because all this stuff just builds up on top of each other. So if I gave you this line, say y equals 4/3 x minus 2, okay? And I gave you a point of, let's just say 7, 6. Nice thing about these is I can just make up whatever numbers now. I don't have to worry about them not working out too well. So it's convenient. And I want to find a line that's parallel to it, this line that goes through this point. So what I need to use is I need to use my point slope form equation, which if you remember is y minus y1 is equal to m times x minus x1. Okay. So in order to use point slope form, we have to know the coordinates of a point, which we have, and we have to have the slope. Well, since we're taking a look at, once again, we're looking at for a parallel line, we should, well, first of all, let's take a look at our slope. Our slope right here, it's 4/3. So if we're looking for a parallel line to this one that goes through the point, its slope should be the same. So basically, let me rewrite this a bit down here. Y minus blank equals blank times x minus blank. Okay. So the slope right here is the easiest part to plug in. Whatever the slope of this line is, regardless of what form it is, or I could even just give you this, you take this, recognize that it's the slope, and you just plug it in right there. And now we're done with this line here. We don't need anything else from this. We're done with it. We just needed the slope. Now over here, let's go ahead and label our points. We've got x1 and y1. Okay. So now, if we take a look here at the y coordinate we need, we go over here to y1, and we plug in a 6 right here. So far, so good. Then if I were to look at the fact that I still need an x1, well, I've got that too, 7. So technically, we have the equation of a line that goes through this point that's parallel to this line, but we want it to look like this. We want it in slope-intercept form. So that means we have to do a little bit of work. This part, so far, we're good. We got everything plugged in correctly. We're good to go. Let's start by doing a little work to this, though. So again, the rule of thumb, we start by taking this number and distributing it to both of these terms, not just one, but both. So that would give us y minus 6 is equal to 4 over 3x minus, and 4 over 3 times 7. Now, if you're not good with fractions again, let's go back to the scientific Desmos. So we have, again, 4 over 3 times negative 7. 4 over 3 times negative 7. And it gives you this long decimal, but again, hit this button here, and boom, makes it easier. Negative 28 over 3. So minus 28 over 3. Okay, good. The next step is to get rid of this number with the y. Since it's negative, we add 6 to both sides. That would give me y is equal to 4 over 3x. So now I have this issue here. I have negative 28 over 3, and I have a plus 6, which again, if you're not good with fractions, we have Desmos. So negative 28 over 3, we're adding 6, and that gives me this number here, which if I convert, is negative 10 over 3. It's minus 10 over 3, and we're done. So this number right here, or this equation here, is what we're looking for. So if I scroll back up, let's borrow this. So this is our original. Okay. And this is our new one. So if we take a look, they have the same slope, which means they're parallel, and they have different intercepts. So we're good to go. So we did everything correctly. This here is a line that goes through this point and it's parallel to this. Now, if we wanted to test this out, it's pretty easy to do. We can just pull back up our graphing calculator. It's a little smaller for a second. So the first line is y equals 4 over 3 x minus 2. So there's our first line. Our second line that we found was y equals 4 over 3x minus 10 over 3. So just by appearance, they look parallel, but this should go through the point 7,6. So let's test this out, shall we? So we go over 7, up 1, 2, 3, 4, 5. Oh, sorry. I'm looking at too small of a scale. That's better. Yeah, because see, these are half blocks, so I was counting wrong. Okay, so over 7, so 5, 6, over 7, up 6. Okay, so over 7, up 1, 2, 3, 4, 5, 6. Yeah, so it does go through that point right there. So they're parallel, it goes to the point, we're good to go. And to be honest, that's the basics of, we don't need to talk about that. That's the basics of this right here. You take this equation or line I give you, or if I just give you the slope, use that. Take the slope, you plug it in your point slope form, and the coordinates come from your point. Plug it in, you distribute, solve it for y, you're done. And if you have any questions, just let me know.